One of my favorite chapters in this Wildi text is chapter 13. Just an excellent presentation in terms of three-phase induction motors, how they work, um, different varieties of three-phase induction motors, walking it through very logically and bringing in a lot of the information that you have built and gathered over earlier courses. And so, again, it's one of my favorites, and we'll spend a lot of time going through this chapter and getting it in the way that Wildy presents it. I really think gives you just this wonderful full understanding of these machines. And so, section 13.0 is the introduction, and he begins by telling us that when we talk about three-phase induction machines, we're talking about both generators and motors. And the reason this is so important is that you in the workplace, working as the technician, the engineer, engineering technologist, whatever your capacity is, the interaction that you're going to have in regard to motors is going to be primarily the three-phase induction motor. Now, let's not get bogged down in that title at this point. We're going to walk through all this, in the way that it's presented, and it'll all make sense as we see how that title is formed. And the first thing that this, when he says three-phase, now, regardless of whether you're very familiar with how three-phase electricity works, or if you're not, it doesn't really matter. We're going to look at it and understand it as we march through this section. So in the introduction, he's got a few things that he points out as we get started with this. So he tells us again that three-phase induction motors are the motors most frequently encountered in industry, and there's a reason for that. The primary reasons that you see them as the most frequently used is the following plus many others. But he tells us that they're very simple, and they really are. The construction of a three-phase induction motor is compared to the DC machines that we looked at is much more simple and easier to understand, I think. They're rugged. You can put them in a lot of environments that they're subjected to a lot of different types of stresses, and they do well in that environment. They also have a relatively low price. One of the big drawbacks with DC machines is just the total amount of copper that is, contained in that machine. And, the three-phase induction machine, it eliminates the need for a lot of that copper. And in addition, the three-phase induction machine, it has no brushes, it has no commutator, it has no slip rings, none of that kind of stuff is needed for this three-phase induction motor to operate. Therefore, there's really minimal maintenance required on it. The characteristics of the three-phase induction motor, now it has basically a constant speed from 0 to full load. Now that can either be good, it's neither good or bad. It's just a characteristic of the motor, okay? And so when we looked at a DC machine, it was frequency, the voltage level determined the speed of that machine, right? And as we increased the voltage, the motor increased in speed. Well, what we're going to find with the AC induction motor, that it's independent, basically. Now, and we'll look at a formula for that. And what we're going to find is that the speed is frequency dependent. Well, most of our electricity is given to us in the United States at 60 hertz. So the speed is predetermined in an AC induction motor. We'll look at exactly why that is, and quantify that in some examples. And then we're gonna look at three basic types, with the primary emphasis will be on the squirrel cage induction motor. Don't worry too much about that till we get there in terms of where that comes from, that term. There's also something called a wound rotor motor, which a lot of applications for that have died away. And then the other one is that it was called a linear induction motor, and we'll look at some of the characteristics of that. And so we're going to go through these characteristics, and it doesn't matter if we're looking at a motor that's a half horsepower to, 5,000. Think of that, 5,000 horsepower motor. These principles that we look at in this chapter, the equations still apply. Everything stays the same. It all works for all different sizes of motors. Okay, so we're also going to see this very interesting transition where we could take a three-phase induction motor, and there's a certain way that we can operate that three-phase induction motor, and so that it actually functions as a generator. Okay, and we'll try to put some real-world examples on there, like hybrid vehicles that recoup energy from the motion, so forth and so on. So we'll look at that as well. Okay, so that's our introduction to this chapter.